Hi guys, in this video we're going to talk about the next form that is available in a complex number, which is known as exponential form. Previously we have learned on how to calculate complex number by using its original form, which is a plus bj, and we also have polar form, which is a form that consists of modulus and angle theta. And in this form, it is just a form that we obtain by simply converting our angle theta into radians, right? So to do that, okay, to convert our angle theta into radian, we are going to just use a formula of angle theta times with pi over 180. Okay, let's try to use the formula. Let's try to see this one, right? Exercise 1.11. So 150, right, times with theta over 180, which gives us 5 over 6 theta. Okay, the same goes for this one. For the second question, just simply times 45 with theta, pi 180, and it will give you 1 over 4 theta, or theta over 4. Okay, now let's do the real thing, which is use it to express complex number into exponential form. So to do that, okay, as you can see, the exponential form is like this, which is r exponent to the power of theta j, and this theta here is actually in a form of radian. Okay, so to show this form, we'll need two things, just like in polar form, which is the the modulus and the angle theta being converted into radian. Okay, so let's do that. So for the first question, in example 1.15, we have z equal to 2 minus 2j. So let's try to get the r for this question. So it is 2 squared plus minus 2 squared, which will give us the square root of 8. That is our r. And then for our angle theta, we have tan -1, -2 over 2, which equal to -45. Now, again, before we proceed and converting it into radians, we need to make sure that this is actually the correct figure. So let's look at it again. A2, just put it like that, and we have B -2, which is at this area, let's say. So it's actually at the 4th quadrant, so 45 there is this area. So we want the area, we want this one. So the way to do that is by subtracting it with 360, which gives us the actual angle theta of 315. Now let's convert that. Okay, so we have 315 times with, okay, pi 1 over 180. Okay, so it is equal to 7 over 4 theta. So these are the two crucial information that we need to have, which is modulus and this thing, right? So let's try to change it in this form. So we have z equal to 8 exponent, and then let's substitute the theta. So we have 7 over 4 pi j. So this is the exponential form for the first one. Now let's try to look at the second one, right? Let me erase it first. Sorry. Okay, so for the second question, z equal to 3 plus 5j. So the r for this one is 3 squared plus 5 squared, which is equal to 34. Right, and then for the angle theta, so it is 5/3, which is in the first quadrant, so 59.04. right, so this is the angle theta. Let's change it into the form of radian. 59.04 times with pi/180, have 0.3285. Okay, let's put it in exponential form. So we have z equal to 34 exponent to the power of the theta, which is 0.328 j. So this is the answer for this one. Okay, so try to do the exercise, and then let's look at the theorem a bit. Okay, in every form they will tell us on how to multiply, how to divide, and how to do this and that. And for that, let's look at theorem 2. So they're saying that if we have two complex number in exponential form, if they want us to multiply between the two, right, you just multiply the modulus, and then you just sum the theta, right, just like polar form. And if you want to divide it, you will divide the r and you will subtract the theta. That is the idea there. Okay, let's try to apply it in our exercise 1.13. We have z1 equal to 5 exponent pi/3j, and for this one z2 4 exponent pi/2j. So they want us first to multiply between the two. So to multiply it, okay, so multiply z1 and z2, okay, which in our property, in our theorem, to multiply it, you need to multiply between the two r. For this case, it is 5 and 4. So we have 5 times 4, and then let's just bring the exponent. As for the theta, okay, theta in radian, we'll need to sum it, which is, we have here 1/3 and 1/2. Okay, so 1/3 plus 1/2 and the theta j. Okay, so and this will give us 20 exponent 5/6 pi g. So that is how you sum it. And for the second one, which is to divide it, okay, so z1 over z2, we need to divide the r, so 5/4, okay, and we need to subtract between the two theta radians, which is, right, just put e here, and then we have 1/3 minus 1/2 pi j, and that will give us 5/4 exponent negative 1/6 pi j. Right, so that's how you do it. Okay, So in the next video, we're going to talk about De Moivre theorem, which is De Moivre theorem, which is it will be about how to deal with a power. If we have a power, we want to calculate for power in a complex number, this is how we do it. Okay, thank you.